All right. So like I said, you want to memorize this column of your chart. Okay, so memorize that one and memorize the bond angles that are associated with them. Now it seems daunting. Okay, it's really not. Let me get you through it, okay? Oops, that's regular chem. Here we go. So valence shell electron pair repulsion looks at the geometry of molecules and the shape that we're going to create, and these charged clouds and how they're going to determine that. Okay, so first of all, you draw the Lewis structure like I taught you. Remember, hydrogens are always on the end, and the least electronegative element is usually the central. You guys are comfortable with that. Count your bonds, establish your lone pairs. You know how to do your Lewis dot structures. Okay, so use the arrangement of the lone pairs in the bonds to determine the molecular geometry provided with the chart. You have to memorize these and the bond angles for the exams. They will not give you this chart. Okay, if there's more than one central atom, they will ask you for a specific element. So let's say, give us the geometry of this element. Now let's talk about the chart. This is one of the charts, but I like the chart that I gave you on the next page. Okay, so that's this guy. Now, when we talk about these, okay, if we're talking linear, that kind of makes sense, because think of my fingers here as being the central atom, okay? If we're here, that's going to be linear. And linear makes sense because that's going to be 180, right? I mean, think back to your geometry. You guys have had some geometry, yes? Okay, you know that a straight line is 180 degrees, correct? Okay, so that one's easy. Okay, then we've got trigonal planar. So trigonal planar, when you have trigonal planar, what does planar mean? You're all in the same plane, okay? So if you've got three things in the same plane, they're going to look something like this, okay? And what's the angle between here and here? 120. It's 360 divided by 3. So that one's easy. The next one is slightly less than 120. So that's not far off from where you're at. And what you're doing here is you've got two lone pairs of electrons. Lone pairs of electrons are closer to the nucleus of that central atom. So because of that, they're going to cause more repulsion with the other electrons nearby. Okay? I got to get one more in there. Let's see if I can do it. This is like making balloon animals, you know. I just dropped one. The other key is to try to do it without popping them. Yay. Okay. So this is what that looks like. Okay. We're trying to describe something in 2 dimensions that's actually in 3-dimensional space. Okay. So the bond angle between the central atom, which is inside here, and these other atoms is going to be a little less than 120 because your lone pair of electrons is pushing down on these guys. Okay, they're getting pushed down a little bit because these are dominating it. Remember, they're closer to the nucleus, so they're causing these to go down a little more. Okay. And you think about this, if you drew this out, you would have the lone pairs of electrons. They'd be right here, and you can kind of visualize that this is almost a straight line, but not quite, you know, almost 120 degrees, but not quite. You know, it's a little less than 120. So you memorize that. Then you move on to tetrahedral. So tetrahedral, again, we're using 2 dimensions to do a 3-dimensional thing. So tetrahedral, these are all similar elements. There's no lone pairs, okay? So the angle here, and this one you just got to memorize, is 109.5. But tetra means what? 4. Okay, so you've got 4 elements. So that one's an easy one to remember, right? Okay, so that's your tetrahedral. Now, if we exchange this out and we take one of these away, and instead of having, oh, I did bent before, shoot. I should have done bent. I'm sorry, I did bent and V-shaped different. Sorry. Oh, now I got myself all tangled up. What?
How would you draw a tetrahedral on like a paper?
I just busted one of them. How do you draw tetrahedral? Okay, so if we have, oops, that's the wrong lecture. Here we go. Here, this is tetrahedral. So tetrahedral, you're going to have a central atom here, and then you're going to have 4 atoms coming out. So that's tetrahedral. And I think this guy's dead. Yeah. All right. So the next one is trigonal pyramidal. Okay, I got a lone pair of electrons and 3 atoms coming off. So when we do that guy, do you see how I have him up here? He's going to push these down a little more. So instead of 109.5, we're going to be at 107.5. And you can think of this as a pyramid, right? Got kind of a pyramid formed here. And that would be, I'm trying to think here. I got one of those here. So that's what that looks like on trigonal pyramidal. So NH4 isn't one, but NH3 is. So if you wanted to see that one, trigonal, so NH3, that would be the nitrogen with the 3 hydrogens. This is going to be trigonal pyramidal. And then I screwed up when I was talking about the other one. This guy was trigonal or bent or V-shaped, and it was slightly less than 120. I showed you bent or V-shaped, and that was 104.5. That was what I showed you with the 2 reds on here. This guy, when I showed you this guy, this is 104.5. It's 2 lone pairs of electrons and 2 atoms. That's like water. Okay, so when we draw these, let's look at our charts and figure out when we draw these. Like a party going on in here. Hey, good job beating Parker. Been in the rain. We secured the rock. Good, thank you.
Like a little trophy, and then it's like a little rock, it's like half the price.
It's supposed to symbolize the king of the rocks in some of the schools.
Do they have it? Just
Is it
what
like
is
every
that?
couple
They
days?
won it last year and used it.
Where to go?
I'm supposed to be having
I wouldn't want to be out in the rain. All right, here we go.
You're standing in the rain.
I looked around.
Yeah.
Stop what you did.
Oh, you weren't here last.
Oh, yeah. No, I was over in the park. I was like.
No, it isn't next.
All right, so let's draw some of these. Let's go back to, is this the drawing? Yeah. So here we're going to have our phosphorus, right? And we're going to have our 6 chlorines coming out of here. Okay, and with that, I have to have 6 times 7 is 42. Plus the 5 for the phosphorus is 42, is 47. And then the 1 extra electron here makes it 48 electrons. Okay. So I've got 48 electrons around here. I want to make sure that I've got them all placed. So I'm going to do 2, 4, 6, 8. Okay, do I have 48 electrons around there? Huh? 6 times 8 is 48. Yep, so we're good. Okay, now we're going to go back to our chart. Okay, we have 6 electrons or 6 atoms bonded to the central atom and no lone pairs of electrons. So bonding, we're going to go to 6 and 0, and our shape is octahedral, and that angle is going to be 90 degrees. Okay, good. What's wrong? Good. Ask me questions.
Did you just write it down then, like octahedral and 90 degrees?
Yep.
Okay.
So if they asked you, so in each, classify the non-bonding pairs of electrons, predict the geometry and the shape, and the bond angle. So octahedral,
So we like don't have to redraw it.
draw again.
Yeah, like we don't have to draw it into the bond thing.
No, not into the shape. No, you're trying to draw, like this would be the tetrahedral here, or the trigonal pyramidal. Okay, and this is a good enough drawing of it. You don't have to try to draw the angles or anything yet. No, and it would be 90 degrees because you can't. You're trying to draw a 3-dimensional thing in a 2-dimensional world. And you're trying to do it for people like me that are not artistic. So no, they don't expect you to be able to do that. Like some of you art people might be able to pull it off, but most of us that are chemistry people, we're more left-brained, and that it's just not going to happen, you know? So no, they don't expect you to do that. All right, we have to figure out here which one of these is going to be our central atom. They're both halogens. Okay, so normally halogens are on the outside, but here they both are. They can both expand their octet. So what does it come down to then?
Electronegativity.
Lowest electronegativity. Remember, your formula is a hint to that. Okay, so which one of these is it? So try to draw this and predict what your shape's going to be. Go. Remember, you got an extra electron there to work with. Oh, wait a minute. I said to remove. Oh, remove. Okay, I did. I removed it from mine. Does yours have? Yeah, I think I removed it before I printed them.
Are these two still?
I haven't. We had lab today, and I just didn't
Okay,
have
so
time
you
to even
didn't
think
talk to
about
any
it.
of them?
No, I didn't have time
Okay,
to even
so-
breathe.
There are some of these that I got information for. Do you want me to just go ahead and enroll them?
Yes, please.
Okay,
Please. Oh
so
God, yes.
I will
please.
do what I can,
Yes, yes.
and then I'll come back tomorrow and.
Let me know whose it is. Okay. Thank you. I'm sorry. Okay, yeah, I removed. There was a typo on here, and I removed that. I think before I.
We still have it.
You still have it? Okay, so remove the the electron. Remove this guy. This guy needs to go away. Because you should have 28 electrons. You're placing 28 electrons. Maybe I ran these and then said to remove stuff. I don't know anymore. I'm trying, guys. I really am. All right, so I got my iodine here. I got my chlorines coming out. 2, 4, 6, 8, 10, 12, 2. Okay, so how many do I have placed now? 8 times 3 is 24. So I still have 4 electrons to place. That means that I've got to put electrons here and here. Okay, so those are my lone pairs of electrons. So now we're going to go back to our chart. We have 3 bonded and 2 on here. 2 lone pairs. So go back and find 3, 2. And that's trigonal bipyramidal. And it's approximately 90. I can't spell. And it's approximately 90 degrees. Okay. So the next one, it doesn't appear to have any typos. So that's good. Let's see if you can do BRF here. Oh my gosh, yeah. Just have it memorized by the time the test rolls around. By the time the test rolls around on the 4th, right? That's when your test is? Yeah, that test. And the one in May. Don't forget it. Huh?
Big AP test is very important.
Yes, if you intend to take it. So BRF cannot expand its octet. So there's no way that F can be the central atom here. If you're working ahead, there's a typo on the next page. Okay, and then this guy, at this point, I would have 7 times 6 is 42 electrons to place. I have 1, 2, 3, 4, 5. I have 40 electrons placed. Yes, ma'am.
How do you know which octets can be expanded?
It has to be in the 3rd period. So like silicon, phosphorus, sulfur, chlorine, because they can bump down into the 3D level. Arsenic, selenium, bromine, krypton, tellurium through xenon, and then astatine and radon.
Okay.
So it's that line. Is it like
It's the line, but not boron, those cannot do it. Okay, the boron line, because there's no 2D level. You can't do it until you hit period 3, and then they can bump into the 3D level. Silicon to argon, but I don't think argon does. I'll be honest with you. I really don't think argon, like, I don't know that it reacts with stuff. But I know krypton can and xenon can.
How do you know not to put a double bond for like the drawing?
Here, fluorine can't have a double bond. That would require fluorine to expand its octet. You can't do that. All right, but I do have 40 electrons. I have 2 more to place, so there's a lone pair on the central atom. So then we go over to our chart. This is 5, 1, so that's square pyramidal, and it's approximately 90 again. All right, good on that page? Other questions on it? Good questions. Keep them coming. All right, here's my typo on this page. I think I've only got one. That's right here. So this should be ICl4 minus. Yeah.
Is it ICl?
The 4 is part of the Cl, so that means that we've got 4 chlorine. And then 7 times 5 is 35, plus the 1 makes it 36 electrons. Does that make sense? Times 6 is 24 electrons.
Are we just drawing them, or do you want the?
Yeah, I want the shapes too. And honestly, guys, it's going to come down to you just practicing. And you're just going to have to keep doing it and doing it and doing it. And as frustrating as that is, it's just the way it is. So this one, what is it? Did you get it yet? Trigonal planar. No lone pairs of electrons here. Okay. We already said that this one is tetrahedral. Mm-hmm.
Can you explain why it's trigonal planar? Because it has 4 bonds, right?
But it's only got 3 atoms coming off. So this, it doesn't go by bonds. It's going to go by atoms. So it's atoms, bonding atoms connected to that. So if it's bonding atoms, it had 3. There were no lone pairs, so it's trigonal planar. Good question. Good clarifying question. Keep them coming.
For NH4,
Mm-hmm.
For the, like the degrees for like the bond angles, is complex, just what we wrote down.
No, this is tetrahedral.
Oh.
There's no, it's just four atoms attached. So it's 1095. Yeah, there's no lone pairs of electrons. It's a -1, not a +1. It's a +1, not a -1. So it's 1 electron away. Okay. So here you should have had 9, but because it's a +1, you only have 8 electrons. Correct? Yes? Yeah, this one's tetrahedral and it's 1095.
Do we have to draw it like in this so it looks like? For like the next one, 5CL4. Do you want us to draw it like maybe it should have like with all those?
So the way I drew it was I drew my chlorines coming off of here. And then I did my lone pairs of electrons here and here. Okay.
Do you have to draw it like that? Or?
No, I mean, you want to try to balance it as much as you can, but it's, you know, I would have started out drawing it. I would have drawn my 4 chlorines around here anyway, just to give it symmetry, right? And then I had to squeeze these guys in somewhere once I figured out that I didn't have all the electrons placed. Because I ended up with 20, what was it, 28 times, so 32 electrons are placed around here right now. Okay, I want to place my electrons. I'd end up with 28 electrons around, and then I was like, oh, I need 4 more. So then I put these on there. Yeah.
Okay, so iodine, it already has, like with the 4 bonds, it already has 8 electrons.
Right.
So how can you just add like?
Because I needed to expand the octet on the central atom in order to get those 4 extra electrons placed. And it's going to go on the central atom. If you expand something, it's the central atom that you're expanding. Does that help? Other questions? Yes.
Alright, for that one, you want us to write octahedral or square planar?
Okay, so we've got 4 and 2. So if we go over here, we're going to find 4 and 2. So it would be square planar. Okay. Now what this octahedral is it's electron domains. Okay. So this has 6 things coming off of it, right? So that's where they get this. This has 6 things coming off of it as well, correct? That's where they get octahedral. This has 6 things. But this is the one that they're going to want to see. It's the geometry of the atoms. They care about the atoms, not the electron pairs domain. Okay? But that's why, like, this one's tetrahedral. You've got 4 things. Here you've got 4 things. 3 plus 1 is 4. So tetrahedral. So that's where they're getting this column from. And it's kind of helpful in a way for you. But that's why I said in the beginning, go with this. This is the one you want to highlight. This is the one you want to memorize. Okay? This just tells you how many things are coming off of it. Okay? But you don't know, are all those atoms, or some of them atoms and some of them electron pair, lone pairs. Okay? All right, and then SO2 is going to look something like this. And of course, like this guy here and this guy that I'm about ready to draw would end up having resonance structures also. So they may end up asking you to draw resonance structures of these. Okay, this one also should have had a square bracket around it and had a minus sign here. Just like this one should have had square brackets around it And it should have had a plus sign here. So sorry about that. I was getting a little lazy. Yes, sir.
What if I put two both oxygens at double bonds?
Good question. That's what I was thinking, and then I looked at my notes and I'm like, oh no, this is good. Okay, so yeah, it would have to, because otherwise sulfur wouldn't have enough. Okay, so here,
And the formal charge wouldn't have.
yep. Okay, so we got that better. Yeah. Let's count. So we've got oxygen. We've got 6 times 3. 6 times 3 is 18, right? 2, 4, 6, 8, 10, 12, 14, 16. Yeah, need 18 there. And I think that's why I had it drawn that way, Matthew. I think I had it drawn like this. Let's see what my formal charge is now. 2, 4, 6, 2, 1, 2, 3, 4, 5. Yeah, I think that's why I drew it like this, Matthew. Thinking about it. I think this is right now. Because if we drew it the way you had it, like this, okay, 1, 2, 3, 4, 5, 6. Well, maybe not. Maybe yours is still better.
Mine would make it all 0.
Yeah. Yeah, Matthew's is better. Matthew wins. Don't let it go to your head.
Too late. Sulfur can have an expanded octet.
Yes, sir. Oxygen can't, but sulfur can expand its octet. So if we're looking at geometry here, then we've got 2 and 1. So 2 atoms, 1 lone pair. So what does that make that? Bent, and its shape is slightly less than 120. Okay, who's still confused? You said I heard somebody saying that they were still really confused.
No.
Okay.
Why is the first one not double bonded?
Well, oxygen can't take more bonds on than that.
But like without the
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24.
we took off the other two.
I think if I did that, if I did this,
It would be sulfur.
and if I did that for this one, should minus has, sulfur should have 6. It has 1, 2, 3, 4, 5, 6. Oxygen should, I would force sulfur to expand its octet, and we don't want to expand the octet unless we have to. So that's, yeah, well, okay, let's do this then. Let's Google it and see what it looks like. SO3 molecule. Lewis structure, SO3 molecule. Well, so yeah, it looks like that's chemistry school. Let's see if we can find, yeah, this is Chegg. They're agreeing with it. Yeah, they have, well, they have it drawn the way I have it drawn. So it looks like there's some various discussions out there for it. Who do we go with, huh?
If we're going off based on formal charge from the 0,
Yeah.
this would be the best.
I'm doubting they're going to give you one that's going to be that icky. But here, Cora is, they said up above it was one thing, and now they're saying something different here. So, oh no, that's the sulfite, no, hyposulfite ion. Never mind. Yeah, it looks like they're going with this one, Natalie. Maybe you are right. Maybe it's a down day for Lippy.
2 for 2.
2 for 2, guys. Stump the Lippy. You're doing good. It's a Monday. There. Better? The geometry's still the same. All right. Chemistry is humbling. That's an extra slide that shouldn't be in there. Okay, polarity. In order for a substance to be polar, it has to carry different charges. Let's see what your homework is tonight, if you need this for your homework.
It's supposed to be ID usually. These are supposed to be on the other side. It's supposed to go to the bottom.
Oh, but there is some polar and non-polar.
Yeah. So you have a lot.
Yeah, but I need to talk to you about polarity.
Yeah.
It's not all, it's to this chart right here. You're gonna stop when you get here.
Yeah, I know. That's a lot. That's a lot. That's like a lot. So much.
No. No.
Are we doing the idea?
What do we go to?
You're gonna stop when you get to this 27A worksheet. If I can get through polarity. I don't know if I'm gonna be able to or not. So then I may have to double check it. All right. So in order for a substance to be polar, it has to carry different charges. It has to have a dipole moment. And we've talked about this before when we were in chemistry, okay? Essentially, stop looking at the clock and listen to me. Essentially, if it has a lone pair of electrons on it, on the central atom, lone pairs of electrons are going to be polar, okay? It also comes down to a difference between polar bonds and a polar molecule. You can have polar bonds. We talked about polar bonds, the electronegativity difference being greater than 0.5. Remember that? You can have polar bonds, but yet still have, or non-polar bonds, but yet still have a polar molecule. One does not exclude the other. Sir? That is not the only way, okay? That is one way. So for example, if I skip to this drawing, okay, I've got my carbon here. I have my hydrogens coming off. I have my chlorines coming off, okay? Remember that these are a two-dimensional representation of a three-dimensional object, okay? So if I'm drawing this, my chlorines have a lot more electrons in them than my hydrogens, yes? Okay? So if you think about this, if I have my hydrogens in here and my chlorines are there, even though this is a tetrahedral element, okay, I'm still going to have more electrons here because of the chlorines. I'm going to have more electrons here than I'm going to have here. This is not polar, is it? Or this is polar. This is polar. It's not non-polar. You've got more electrons here, so you've got a greater negative charge here than you would here. Okay? So if we were to draw this in, I would actually draw this a little differently. I would draw my chlorines over here to kind of show that the other way is fine too, okay? But if I'm drawing this, I'm going to draw it like this, and I'm going to draw an arrow this way and I'm going to say that the positive end or the positive dipole is over here, and this would mean that I've got more negatives over here. Do you see how you have more negatives here? The other way to do it is, instead of the arrows, you can do the S with the squigglies. Backside. Okay? This guy is tetrahedral, but it's nonpolar because it's all symmetrical. Okay? Imagine I had all red balloons here, all the same size. That's going to make that nonpolar. So this is nonpolar. This guy is polar. It comes down to symmetry. This would not be symmetrical as far as electrical charge is concerned. Okay? So even though this bond here is a nonpolar bond, this molecule is polar. Polar bonds do not mean that you won't have, nonpolar bonds don't mean that the molecule won't be polar, and vice versa. This is a polar bond, but this is a nonpolar molecule.
How would you check the polarity of bonds with that? Would you do it?
Electronegativities. But you're not really concerned about those right now. You're more concerned about the fact the whole molecule as a whole. That's what you need to be focusing on. Okay? So yeah, I want you going through this chart. I will have the video uploaded. I will have, oh, wait a minute. Hold on. We didn't get to hybridization. So anywhere that it talks about hybridization, ignore. But I want the rest of it done. So I think that's all but there's a couple places that talk about sigma pi bonds and hybridization. We didn't get to that today. We'll pick that up tomorrow. So just try to do the geometries. Try to do the geometries and the polarities for that stuff, okay?
You want to do IDD and do this?
Yeah, but I don't want you to do hybridizations, and I want you to try the polarities, okay?
What about bond length and bond order?
We didn't get to that. If we didn't get to it, don't do it.
All right.
Okay? So if we didn't get to bond order, bond length, don't do it. Let me stop my recording.